Lesson 81, using natural logarithms. They follow all the same rules as regular logarithms, they're just spelled differently. So if you have b to the x equals a, if you remember, that's log base b of a equals x. Now for natural logarithms, we have e to the x equals a. That means the natural log of a equals x. So the base is just e. So it's a log base e. And instead of writing log base e, we just write ln. It's just called the natural log. So if you had e to the natural log of x, because the base is equal to the base in the log, it's just equal to x. So it follows that same rule. The natural log of e to the x just equals x because the base is the same. And this is true where x is greater than 0. So, for example, if we had e to the natural log of 2x, that's just going to equal 2x. If we have the natural log of e raised to the 2d squared plus d, just equals 2d squared plus d. We have the product property, the quotient property, and the power property. They're all the same as with regular logarithms, only now we have a natural logarithm. And the power. The quotient property, the product property says that if you have the natural log of a product, it's equal to the natural log of each factor and then added together. So when you have a product, it's just the natural log of a plus the natural log of b. The quotient property says that if you have the natural log of a quotient, it's just equal to the natural log of the numerator minus the natural log of the denominator. And then the power property is the natural log of a to the p power. You can just put that power in front and you get p natural log of a. If we had y equals e to the x and we want to find the inverse, if you remember, we swap places, the x and the y, so x equals e to the y, and then we have to solve for y. To solve for y, you can take the natural log of both sides. So we have the natural log of x equals the natural log of e to the y. Natural log of e to the y follows this rule, so just be y. So y equals natural log of x. And I use the symmetric property and switched sides here on you. But these two functions right here are inverses of each other. So we started with y e to the x, we swapped the x and y and ended up with y equals natural log of x. So an example of a problem we might do using logs is 3 natural log e to the 6x squared. Now, natural log of e raised to this power is just the power because these cancel out here. So we have 3 times 6x squared, and that's going to give us 18x squared. Another example, if you have natural log of 10e. 10 and e are two factors, so we can use the product property. and take the natural log of 10 plus the natural log of e. Well, natural log of e is just equal to 1. So we have the natural log of 10 plus 1. And so this is simplified, would be that. Then if we have a quotient, natural log of 4 c cubed divided by e squared. So we could take sorry, and I meant to raise it to the 4th power. Yes, we're going to use the quotient, the power, and the product property. So we're going to take this 4, put it to the outside, and then we're going to subtract those two. So natural log 4c cubed minus, instead of putting parentheses, I'm just going to distribute that 4 inside natural log e squared. This is super fun. Okay, so then we have a product property here because these two are factors. Now the 4 is not cubed, so I can't bring the power down until I separate it. So 4 natural log of 4 plus 4 natural log of c cubed minus natural log of e squared is just 2. So 4 times 2 is 8. And then this one I'm going to use a power property and bring the 3 down to the front. And that's simplified. So we just did the quotient property where we subtracted. When you bring the 4 down, you have to do 4 times each one. Then we separated this into the product of both. Simplified this to be 2 times 4 is 8. This stays, the power comes over here, and you get that. There's a couple of more formulas I need to give you. A equals PERT. This is one of those. I'm pretty sure we've seen that before. E to the RT. And then a growth model. N sub naught is just the initial amount, e to the kt, and that's for growth. And for decay, your k would just be a negative number. And that's for decay. So we'll use those throughout the homework also. That's the end of this lesson.